In this video, I'm going to fully explain the details of the process of changing from standard form to graphing form, because that is the second big idea today, being able to take something that looks like this, and y equals 2x squared plus 4x minus 30, which is currently in standard form because standard form is of a parabola as y equals ax squared plus bx plus c, and being able to change that to graphing form, and that's what 4-37 does. I'm assuming that you did relatively well on 4-35 and 36 because it's just naming the vertex location and doing other things with the stretch factors, moving it right and left and so on. So the big idea though, the more of a detailed thinking question is this 4-37. So let's take a look at how you find the average of the x-intercepts and how that helps you find the vertex location, which you can then change into graphing form. So here goes. First move needs to be to factor this, because once you factor it, you can find the x-intercepts. So the way to do that is to say, okay, well, I've got y equals, and the first rule of factoring is take out any common factors. Do they all have something in common? Well, of course they do. All of these numbers are multiple of 2, so I can divide them all by 2. Now I've got it like this. If I set my equation equal to 0, then as soon as I set my equation equal to 0, then I've got the ability to find the x-intercepts, because if you want to find an x-intercept, you plug 0 in for y. So that's what I'm doing here. So now let's go ahead and factor it. If I have a hard time factoring x squared plus 2x minus 15, I can always go to a generic rectangle and a diamond problem situation. So I put the x squared in the first box, so that's going to go here. Put the minus 15 down here, that's negative 15x squared. I've used those. And then I still haven't used the 2x, so I'm going to put that down there. So two numbers that multiply to negative 15 and add to 2, and that would be negative 5x, positive 5x and minus 3x, because a positive and a negative make a negative when they're multiplied, and then I have to have two more positives. So then I just bring the 5x and the negative 3x back over here. So I'll put the 5x here, the minus 3x here, and x times x makes x squared, plus 5 minus 3 gives me my two factored parts. So now I've got this broken down into 0 equals 2 times x plus 5 times x minus 3. And now immediately I know that my x-intercepts are when this equals 0 or when that equals 0 by using the zero product property. So then I know my x-intercepts are located at negative 5 comma 0 and 3 comma 0, and that comes from when either of these pieces would equal 0. I mean, you could go over on the side and do this problem, subtract 5 on both sides, and you get this, and x equals negative 5. And you can do the same thing with the 3. Okay, so now I know that. So now that I can kick into a graph. So I could say, okay, here I'm in business. I know I've got an x-intercept at negative 5, so I could put a dot there at negative 5. I know I've got a x-intercept at 3, so I could put a dot at 3. So 1, 2, 3, and then 1, 2, 3, 4, 5. So I've got a dot at negative 5 and positive 3, and so I've got that going for me. But I still don't know everything about my parabola. I don't know, exactly how this thing is looking. So I'm at this point of graphing this, and the next move after putting your x-intercepts on is to find the middle, because we know a parabola is symmetrical. So because it's symmetrical, I can use its symmetrical property to know that this thing is going to do this, and it's going to have a line of symmetry. So I need to find that location. It's called taking the average of the x-intercepts. So I'm going to take the average over the x-intercepts, which is pretty easy to do because I just add these together and divide by 2. So I take negative 5 plus 3 and I divide it by 2. Negative 5 plus 3 is negative 2 over 2. So my average of my x-intercepts would be negative 1. So I go back to negative 1, and I know I'm going to have a line of symmetry through this dashed line, and I know my vertex is going to be on there somewhere. So then what I need to do is, now that I know that my vertex has an average at negative 1, then I know it has an x value of negative 1. So then I can take that negative 1 and I can plug it into the original equation. So what I'm going to do now is I'm going to say, okay, I've got y equals 2 times, well, the original problem is 2x squared plus 4x minus 30. I know my x value has to be at negative 1 because that's my average of my x-intercepts. So I just simply do that. I take the negative 1, plug it in for x, and do that in both locations where the x's were, and then multiply that out. Well, negative 1 squared is 1, so that gives me 2. This is minus 4, minus 30. Well, 2 take away 4 is negative 2, minus 30 is negative 32, so my y value is negative 32. So in this particular case, I know I have a point at -1, -32. So let's say that that's the location. Now that is pretty important because now I know my vertex. So that is my vertex, and that is my h comma k, because we know that vertex form is hk. So there's my h, there my k. That is your x and y values that are working for the vertex. So what I can do then is I can say, okay, great. As soon as I know the location of the vertex, I know that the parabola is going to do this, and that's what it's going to look like. But then I also know how to get it into graphing form, because I would have y equals, well, here is my h, here is my k. I do have a stretched out parabola because I have a 2 multiplier out front. So I'm going to put the 2, there's my a value, and this thing has to open up because I know it has this location of the vertex and those x-intercepts. And then it would be x, oh, here's my h. My h is -1. Well, if you think about this, if my h is -1, this is a subtraction-based equation. So we think of that as minus -1, and then it would be squared, and then minus 32. Minus 32 is my k value. No, nobody really is ever going to do this minus and negative stuff. So realistically, what you're going to do is just put a plus there, because you have a subtraction-based equation that has a minus value going in. It's going to end up being an addition statement. So y equals 2 times the quantity x plus 1 squared minus 32. This is now in graphing form. Okay, and that's where celebrating, because graphing form is awesome. I know immediately that my vertex is at -1 because I can tell by looking at there, -32, and that's what graphing form allows us to do. I can tell it's a parabola that opens up because I have a +2 as my a value, and it's a little bit stretched out. So it's a stretched out, skinny kind of parabola. So the whole point of this is be able to take an equation that is given to you in what is called standard form. So this is standard form right here. Okay, where it's all long and you can't really tell much about this. I can't tell the location of the vertex by looking at that. But as soon as I take the average of the x-intercepts, plug that back in, I can then get it into graphing form, which is here. And that is the big point. So you are going to be asked to do some questions here next to practice that strategy. Now the one thing I want you to get into the habit of right away is checking your answers. So what I do is I go to my calculator, I turn it on, and I type in both equations. So here's the first equation, the original, here's the second. And then to make sure that you've got this right, all you got to do is go second table. If my numbers match up in my table, then obviously I've changed it from standard form, which was my y1, into graphing form, and all of those numbers are the same. It's the easiest way to check. Type them both in, go second table, and you can verify that you've got the same equation. Now, the steps that we just did, if you want to know the steps to change it from standard form into graphing form, step 1 is you have to find the x-intercepts. Okay, if you don't have the x-intercepts, you can't do anything. Step 2, you need to take the average of the x-intercepts, because the average of the x-intercepts gets you to the line of symmetry. It's going to give you the x location of the vertex. Okay, and once you have the x location of the vertex, then you can plug that x value in. So plug x value into the original equation. And once you plug it into the original equation, then what you're getting when you do that is you're solving for y. You're going to figure out the y value of the vertex. Now you know the x and y value of the vertex, so you can locate the vertex. The vertex is the key point because the vertex is telling you h and k. So step 5 would be simply go ahead and draw the graph. Because now, after you've got the vertex location, you can easily draw the graph. And then from there, once you've got the graph drawn, you can then, step 6, you can write the equation in graphing form. And the graphing form comes from your h and k value. And then, of course, after you do that, step 7 is to check. And what I mean by check is put them in y1 and y2 on your G-Calc, and then check the table. And once you go to the table, you will see that they are matching and you've got the right equation. So it is kind of a 7-step process, but realistically, if you think about it, it is all about finding the average of the x-intercepts and then plugging in that number to find the y value, and then you've got your h and k. Now, what you would need to do next then is work on question 4-38, and then after you do question 4-38, please make sure you check it on your graphing calculator by plugging in the original and the new equation, and then turn in 4-35 through 38. So 4-35 through 38 should now be a complete after you finish this and turn those in, and then you can start on the homework. And the homework is 4-39 through 45, and then that will be due, obviously, tomorrow. Have a great day.